So we're going to look at a different form of the quadratic, okay? Recall that there's standard, which just looks like that, okay? That's the one we've been contemplating and working with extensively, right? And I told you we just recall what A and C tell us just by looking at the equation. But now we're going to learn about the descriptive form, which looks like this. Okay. Just make sure you have that written down. Especially the new one, right? The descriptive form, you should have that on your study sheet. Right? Where about y is equal to x. Yeah, this one. This one. Okay. That's just 4, 5. I'm just going to cover that for now. Yeah, and then I'll get to it. Okay, so Lance and Kamalpreet, I see yours, but it still doesn't show as turned in. I can see the file. So make sure you press turn in. And then I'm going to call out names now, okay? Yuvrach, Gavin, Amrinder, and Marianne. I still need your submissions, okay? So try to get it in, okay? All right, so one thing that's very important here, and maybe I will use a different color because otherwise it's the same highlighting everywhere, is this part, okay? That part right there. And I'll add that the sign of H changes when taken out of equation. And you'll see, we'll do some examples later. But whatever the sign is in the equation, it changes when it comes out, and that negative takes care of it. Okay? So the descriptive form doesn't give us the y-intercept at all, but it does give us the coordinates of the vertex. So that's where that sign comes from, okay? So it gives us the vertex, and still A still does the same thing. Tells us the width and the opening, so that doesn't change from when you compare these two. But this one actually tells us what the vertex is, the actual coordinates, the location of the vertex. So it's quite handy that way. So here are some examples. So variations of the descriptive form. Okay. Sometimes some textbooks call it the vertex form as well, so it's the same thing. Okay, so if you're given an equation like this, okay, it tells us we can take the vertex out right away, but watch what happened here. I'm just gonna put it this way, here and here. See how the sign changes when it comes out? So when you take it out of the equation, the sign changes. Okay, that's very important. Because if you put a -4 into h here, right, the -4 and this negative here turn into positive. That's why when you write it out, when you plug that -4 in, it turns positive in the equation. So when you take it out, you have to change the sign again. Okay, so here's another variation. Okay, so let me take some scrap here on the side, okay? So let's say I told you that the vertex is -4, 5, okay? And you're saying, okay, write the descriptive equation with a vertex with -4, 5, okay? So if I were to take this equation, I would go y is equal to a x minus, because that's what the formula is telling me here, and then I grab h, which is what? -4, right? And you substitute that in. And this would be squared, and then it's plus 5. The one outside here is not changed. But the two negatives here, what happens to those? Yeah. So that's why you just have to remember, if I gave you an equation like this, and I asked you for the vertex, it is 4 and 5. Those are the two values, but you have to know that the x value will have changed its sign. You have to, I just tell my students, when you take it out of the equation and you state the vertex, just change the sign. If it's negative here and you take it out, it'll be positive there, and vice versa. Okay? Good question. Here's another example. So I kind of just throw in like weird decimals so that it shouldn't throw you off, okay? So here it is again. First of all, you should be looking at this equation and recognize that it's in descriptive form. How do you recognize that? It's quite simple, just the brackets. The brackets with a square, that should give it away. That's a dead giveaway. Okay, so you're not going to have to guess. It doesn't look standard at all, right? So here it is again. I'm going to highlight that. And basically there's a positive there, right? There's technically a positive there. The sign changed again when you write it, right? Sign changes. So that's the most important part about the vertex. I didn't address this because I'm assuming you know already, right? A is negative, so we'll be pointing down, and it's also actually 1, so it's just a normal curve, okay? Because A is negative, A is equal to 1, right? So these two things tell me that's still the same as before. Over here, we know it's up because A is positive, and we know it's wide because A is in between 0 and 1, right? And then here, my vertex would be negative 0, 1, 7, 5, sorry, comma. What's my y value here? What's k in this case? It's 0, yeah. So don't be alarmed if it's not there, okay? So and this would be up and this would be narrow because it is slightly bigger than 1, right? A is bigger than 1 and A is positive. Okay. Next, I will put this, I put this down. Usually I don't do this, but I thought with the online thing, it's common errors for students to think that the constant at the end is the y-intercept. So they'll take this equation, for example, and be like, oh yeah, the -7 must be the y-intercept. It's because you forgot that this is actually in descriptive form where that last value is the y value of the vertex and not the y-intercept. So I would recommend you writing it down so you know. I guess when you go over your notes, it'll be a reminder for you. Number of x-intercepts, and you can just copy that down and I'll give you some sketches here on the side so you can picture that. So for the first scenario, if you look at the descriptive form and you notice that A and K both have the same sign, what is that telling us? This means that it's pointing up, and a positive K value means that you're going to be above the x-axis, right? Because that's the y value of your vertex. So this would be, right, K is positive and A is positive, right? That a parabola would be somewhere above the x-axis. If both of them are negative, so they have the same sign, that means that it's going to open down, and the K value, right, K is negative and A is negative. So same sign means that it will never cross the x-axis. Opposite sign, so if A is positive and K is negative, that's when you have the two x-intercepts. Okay, so A is positive, K is negative. A is positive, but K here is negative. And the other way around, if A is negative and K is positive, right, the y value of the vertex is above the x-axis, you also will have 2, right? And then if K is equal to 0, A doesn't matter, right? A doesn't matter here. If K is equal to 0, that means that you're right on the x-axis. Okay, so you look like this. So it's either right on it going down or the other way around like this. And you're right on it. So K is equal to 0, K is equal to 0 here, A is positive, A is negative. So the value of A doesn't really matter. You're only going to have one x-intercept. So here, we're going to say no x-intercepts, 2 x-intercepts, 1 x-intercept. And again, it doesn't matter how scary the equation looks. You always plug it into your y1 and you can answer anything you need to answer, right? You have the graphing calculator at your disposal. So that's always your last resort, right? If you don't remember these things, you can always plug it in and see, right? But I might ask you, why is it just by looking at the equation that it belongs to one of these categories, right? Okay. All right, so I'm gonna have a few examples here. I'm just gonna let you copy up to there for now, okay? How many x-intercepts are there? And so this is an A, B, and a C, but the C is gonna go back to A and B. Go ahead. And also, the groups that are not here today, when you come in next week, there are 4 handouts sitting on that little cart on wheels. So as you come in, you can just help yourself to one of each. So that's already reviewing for the test. And hopefully I'll have more cords here so you can grab one of those and charge them, okay? Charge your calculators. So just remind me if I forget to mention it, okay? Okay, so how many x-intercepts are there? Here, we would have to say that A is negative and K is negative. So since they have the same sign, no x-intercepts. Okay, they would literally be both negative, right, and go down like that. This one, A is positive, K is negative, opposite signs, therefore 2 x-intercepts. Determine the y-intercept for A and B. How would you do that? For A, it's not -5. You have to use second trace 1. Remember I showed you how to do that? And x is equal to 0 for that. B, you do the same thing. So let's use our calculators, and so I already typed in the first one, the one in A. So remember, this is how you type it in, so it would be good practice for you to do that right now. Know how to type it in. I don't see a thing, right? By the way, I'm turning off plot 1 because I'm not using L1 and L2. There it is. So what I'm going to do is zoom 6. Zoom 6 gets me back to the origin, and what did I do there? Oh, I put 2 X's in there. Okay, anyways, there it is. It's right there. And watch this. Do you notice where your vertex is? It's at, even though it's positive 4 here, it's really at what? Negative 4, negative 5, right? So there it is. Where's my y-intercept? My y-intercept is going to be way down here. So I need to go to Window, decrease my y-min to minus 30 maybe. Still not, so I'm going to do it. I'm going to do even more. Negative 50 perhaps. There it is. Now it's crossing. Now I can go second, trace, value, x is equal to 0, and my y-intercept is negative 37. Okay? So y-intercept is 0, negative 37. And watch this, you can see also that there is no x-intercept, okay? Which we already predicted up here, but now it's confirmed, okay? Let's type in the other equation there. Bracket, use your brackets, right? And there it is, 2 x-intercepts, which we predicted. I'm going to change my window. I'm going to increase my y max to 50. And there it is, it's crossing now. Second trace 1, x equal to 0. That's 37.2. As 0, 37.2 there. Okay. Oh, okay, I see, Lance. Yeah. I see what you're saying. So while Lance, I'm going to do this for now, okay? That's the one you were referring to, right? Can we just write this down here? This part right here, and then we're done. Just what the intercept is, it's 37.2. Yeah. Okay. I'm just going to do A, and then I will give you some homework, okay? Write the equation that would satisfy the following conditions. This is the vertex, you want it narrow, and you want 2 x-intercepts, okay? So we know that this is we need it in descriptive form because the vertex is provided to us, okay? So we would go y is equal to, I'm going to leave A for now, but I'm going to put down x Since this is negative, it comes in here positive, okay? So I'm going to take care of the vertex first, and the y value stays the same. You want it narrow, so that's easy. Just make a greater than 1. You want 2 x-intercepts.
Pardon the interruption. Any band students who are currently in the building and are attending the outdoor rehearsal today, would you please stop by the choir room, room 45, and pick up a music stand and take it with you out to the senior gym doors? And would Mr. Witzke please report to the office?
That would make it narrow. To have 2 x-intercepts, you need the signs to be opposite, so you would go negative. This is a possible equation that would satisfy those conditions, okay? Okay, so homework. This is the textbook. Finally, back to the textbook. Page 417, okay? I'm going to get you to do 1, 2. So I'm not going to give you a whole lot. 1 to 5. A lot of graphs there. And then 11 to 14. And that's it for today, guys. If you're online, happy Thanksgiving. Happy Thanksgiving to you too here. You can hang out. Yeah, see you. You too. See ya. Yeah. Yep. Absolutely. Let me just find it. Yeah. See that text there? If you looked at my screen, I made that mistake. That's my bad. Yep. Did it work? Oh, yeah.